Hello everyone, here is a brief overview of this paper. This paper is about making streaming ASR better by leveraging non-streaming models. So briefly, the difference between streaming and non-streaming models is that non-streaming models have access to the full audio sequence before making predictions, and therefore are usually better than streaming models that only have access to limited context. Most prediction models, however, require streaming models, such as closed captions, for example. So that's our constraint. We want to deploy streaming models, and we're going to leverage those non-streaming models to do so. So the method can be described as follows. There is a set of unlabeled data that we get from YouTube videos and that we segment using a random segmenter. And then those segments are labeled using an ensemble of non-streaming teacher models. So that's streaming student models that will meet our requirements. Can be trained on top of those pseudo labels. The ensembling method we use for the teachers is called ROVER, and is basically done using a majority voting scheme after iteratively aligning the output of different teachers. In our experiments, we have two RNN-T teacher models and one CTC teacher, and we evaluate all of our models on a test set made out of long utterances from YouTube. After running experiments, we see that the teacher ensemble is not only better than any other teachers in terms of WAR, but it is also the best teacher to learn from. And something interesting we see also is on the CTC side, that we see that CTC teachers, despite being worse than RNN-T teachers, often lead to better students. So that was a bit surprising at first, even more so as student RNN-T models trained from these CTC teachers outperform their teachers. So one hypothesis we have is that CTC and RNN-T models, being different types of models, will make different kind of errors. And therefore, the student RNN-T model is able to correct very basic mistakes made by the CTC teacher. But if the types of errors made by the students are the same as the types of errors made by teachers, then the errors may propagate better. So this basically improves over our previous work, from which we only used one RNN-T teacher and similar training data. And finally, in our ablation studies, we show that having one CTC model in our teacher ensemble makes a big difference for a streaming model, but using a diverse set of teachers is always preferred. And for future works, this approach can scale very easily simply by getting more data.